Good morning, Geometry Honor students. Mr. Chen again. So this one is a brand new chapter. So it's chapter 9 for the Big Idea textbook. So it's section 9.1. So for this unit, we'll talk about the special right triangles, using the properties of a right triangles, like the Pythagorean theorem or the Pythagorean inequality to classify the triangle. And also mainly we'll talk about the use of a triangle, the way to solve for the triangle. So besides the right triangle, we do have acute obtuse triangle. So we'll get to the law of cosine, the law of sine, all that. Okay, so one thing at a time. So started with that section 9.1. So Pythagorean theorem, objective. So use the Pythagorean theorem and its converse. And number 2, recognize the Pythagorean triple. So here's the one that we have for the Pythagorean and the Pythagorean converse. So if a squared plus b squared is greater than c squared, so then the triangle, it's acute. If a squared plus b squared equals c squared, so then the triangle, it's right. If a squared plus b squared, it's less than c squared, then the triangle, it's obtuse. Again, a, which is considered the shortest leg of the triangle, b would be the medium, and c would be the longest leg. People claim that it doesn't really matter, but let's just put it in the easier way. So a, pretend that it's the shortest leg, b, it's the medium, and c will be the longest leg. Okay, so once we satisfy all those conditions, so we can classify the triangle. So here's the first example. Find the perimeter and the area of a rectangle whose diagonal is 25 centimeters long and whose width is 7 centimeters long. Okay, so first thing that you want to do, so you want to draw the diagram. So we do know that it's a rectangle. Okay, so the length, the width, and also that the diagonal. So what we noticed already, so width is 7 centimeters long. And the diagonal is 25 centimeters. So you might be wondering the length it's missing here. So basically using the Pythagorean theorem. And the reason why that we can use the Pythagorean theorem, because that it's a rectangle. So it's a special parallelogram. The properties of a rectangle, so all 4 angles are 90 degrees. So that's why we can use the Pythagorean theorem. So L squared plus W squared equals 25 squared. So L squared, W, so 7 squared equals 25 squared. So 7 squared is 49, 25 times 25, 625, and then solve for L. So 625 minus 49. So this one will get 576, and then take the square root of 576. So square root of 576, which is 24. Okay, so this one is also considered the Pythagorean triple. We'll talk about that Pythagorean triple. So once we get the length, so basically we can get the perimeter, we can get the area of the rectangle. So centimeters. So the next step, you want to get the perimeter of the rectangle, which is 2 times the sum of length plus W, or it could be written as 2L plus 2W, depends on which way that you want. So 2 times the length plus W, so 24 plus 7, so we get 31. And then 31 times 2, then we'll get 62 centimeters. And then area, length times width, or base times the height. So what we found here, so 24 times 7. So 4 times 7, 28. 2 times 7, 14, plus 2. So 168 square centimeters. So there's 3-step problems. So find the missing length first, using the Pythagorean theorem, and then plug in a number back to the perimeter formula of a rectangle, and the area, length times width. So for this type of problem, we'll get back to it, once we get to the similar right triangles, the comparison of the similar right triangle with the overlapping right triangle here. So let's move on to the next one. So example 3, classify the following triangle by using Pythagorean converses. So this one, again, as what I pointed out earlier, so the shortest leg, it's always being labeled with letter A, medium leg, B, So c would be 6. So using that, the Pythagorean converse. Okay, so we want to compare that the sum of that a squared plus b squared to the results of c squared. Okay, so a squared, so 4 squared, b squared, 5 squared, c squared, 6 squared. So 4 squared plus 5 squared, so 16 plus 25, which is 41, and then 6 squared, which is 36. So this one is showing that a squared plus b squared is greater than c squared. So if that's the case, so going back to what we talked about for the theorem, the converses, so this one, the triangle, it's a cube. So if a squared plus b squared, it's greater than c squared, so the results, so that means the triangle, it's in a cube triangle. So here's another one. So a is 5, b is 12, so c is 13. So it looks like this one is kind of like a Pythagorean triple, but let's find out. So 5 squared plus 12 squared, compare the results of the sum of this two number to that 13 squared. So 25, 12 squared, 144, 13 squared, 169. So 144 plus 25, which is exactly as the same as what? 169. So since they're equal, so a squared plus b squared equals c squared. So therefore, the triangle, it's a right triangle. Okay, so it's a right triangle. Okay, so now let's see what else that we have here. Pythagorean triple, as what I mentioned before. So anytime that you see that the number, the integers can satisfy the Pythagorean theorem, a squared plus b squared equals c squared. So that means, so it satisfies the condition of the Pythagorean triple, or the Pythagorean triplet. So 5, 12, and 13, we did it already. It is. So just verify that. 5 squared, 12 squared. So that equals exactly 13 squared. So what about 10, 24, and 26? Okay, so you may be wondering, from 5 to 2, from 5 to 10, so we multiply by 2. From 12 to 24, we multiply by 2. 13 to 26, we multiply by 2. So it looks like this one is going to be the Pythagorean triples as well. Okay, so we just want to raise up, just want to double the number. So this one it is. But also you want to verify that. So 10 squared plus 24 squared. So it's going to be the same as 26 squared. So 124 squared, which is 576. And then 26 times 26. So 36, 12, 15, 12, 5. So 6, 7, 676. Exactly the same thing. It is the Pythagorean triple. And also, as you can see that if the number that involved with the irrational number, like radicals of 3, radicals of 5, once you do that on the calculator, it's like a non-repeating, it's like a repeating, or the decimal that goes on forever. So this one would be considered irrational. If you see the irrational number, so that means those numbers they're not considered Pythagorean triple. So this one would be no. And this one here looks like that would be the Pythagorean triple. You might be wondering, the root 7, it's not part of it. Well, the thing is that what happens if I divide everything by root 7? So this one, it turns out to be 3, 4, and 5. If that's 3, 4, and 5, so that's like 9 plus 16, which is what? Equals 25. So that would be the Pythagorean triple. So this one is a little bit tricky. If all those three numbers, they share with like the greatest common factor, like root 7. So once we divide it, so we end up with 3, 4, 5. And then using the Pythagorean theorem, so it satisfies that a squared plus b squared equals c squared. So therefore, all those three numbers, they'll consider Pythagorean triple. Okay, so prove the following right triangles are generated by that Pythagorean triple. Okay, so basically just plug in that. So a, b, and c. So m squared plus the quantity of m squared over 4 minus 1 quantity squared. Would that be the same as m squared over 4 plus 1 quantity squared? So basically this one you just want to verify both sides. So m squared, just leave it like that. Binomial expansion, so m to the power of 4 over 16 minus 2 times 1 times this quantity. So which is 2 times m squared over 4 and then plus 1. And then on the right hand side, so binomial expansions, so m to the power 4 over 16 plus 2 times m squared over 4, and then plus 1. And you may notice that things we can reduce, so 2, 4, so that would be 2. So we got m squared minus 1/2 m squared. So then that would be 1/2 m squared. M to the power 4 over 16, nothing we can do, just leave it like that. Plus 1, nothing we can combine it with that constant, just leave it. And just compare the right hand side, so it looks like it's going to be the exact same trinomial. So you might be wondering, do we need to put it back from the greatest power to the least? Not necessarily, so this one can swap it. Again, cross cancel, so m squared over 2, and then plus m to the power 4 over 16 plus 1. So it's the exact same 4-degree trinomial. So basically just keep it, that's the way it is. Okay, so now what about for the other one? So similar situations with the radicals, the a plus b over 2, so it looks like it's a little bit complex. But again, using that, the Pythagorean theorem. Okay, so let me just pull this out. Okay, let's put it to the new slide here. Okay, so using that, the Pythagorean theorem, so what we found here, we got A, which is this one, B would be that one, and then C, the hypotenuse. Instead of using A, B, and C, let's say that X, Y, Z, because A, B, is A and B, they already use. So we don't want to duplicate it. So X, Y, and Z. So proving that Pythagorean theorem, so we got A minus B over 2 quantity square plus square root of AB quantity square. Would that be the same as A plus B quantity over 2 and then the quantity square? Expand it, so this one would be considered 1/4 or over 4. On top of that, expand it, binomial expansion. So it's A squared minus 2AB plus B squared. And then this one here, just consider AB. So you might be wondering, this one can combine those like terms. Definitely we can do that. So convert that to the same denominator. So 4AB over 4. So what we found, the right hand side here, we got A squared. Okay, put this all together with the same denominator. So negative 2AB plus 4AB. So we got positive 2AB plus B squared. And then over 4. And then the right hand side, if you try to expand it, would that be the exact same thing? So A squared plus 2AB plus B squared all over 4. Exponent, distribute, top and the bottom. So both sides are exactly the same. So basically just 1/4 times the quantity of A squared plus 2AB plus B squared. Okay, so for the Pythagorean, the converses, so make sure that you know how to utilize, and then classify the triangle. Again, this type of problem, similar right triangle, we'll get back to it. We'll get to one of those lessons for this unit, which is sections 9.3. Alright, so thank you for watching the video today. So I'll see you guys next time. Bye.